Hey yo, what's going on my ASVAB party people? Anderson here, your ASVAB coach, and in this short video, well, not really a short one, you get a treat today. It's a 2-hour recording of a class that I just did yesterday, now that I'm filming this. We're doing distance, rate, and time word problems. It's a great treat for you. I know a lot of people have trouble with this, so here it is. Make sure to press that like and subscribe button, smash that thing, because it's important for us. That way we can keep supporting y'all. So if you could do us that favor, that'd be great. And also, if you like what you see and you want to join my program, let me just tell you quickly about it in 10 seconds or less. Long story short, in my all-access program, you get access to me to ask any questions that you need to. You can text me whenever you want. Number 2, you're going to go ahead and get access to all the classes and every single recording. That includes over 200 classes, their recordings that I've already done, already there for you. And lastly, over 1,000 extra practice problems to help you raise your confidence and boost that score. So long story short, if you want the all-access pass and you want to raise your score with me, check the link in the description. You're good to go. So without further ado, my party people, let's go ahead and get to it. Let's take to the ASVAB. All right, my party people, let's go ahead and get started here. Let's go. So we're going to need to make sure that we take a lot of these notes down. This is going to look like a lot, but honestly, once I actually explain what this all means, it'll be all good, okay? So first things first, we're gonna understand what the heck we're gonna be talking about today. Then number 2, we're gonna go ahead and watch and learn as I show you some of these problems. Then I'm gonna turn it over to you guys. I'm gonna let you guys practice as well while I go ahead and review every single problem with you. So we're gonna be hyper-focused today on one of the types of rate problems. So that way we can really get used to this, used to word problems, and really grow at the end of the day. So go ahead, take a screenshot of this. Let me make my head a little smaller, actually. So let me go ahead and go here. That way you can see all of that. Cool. So there we go, guys. Go ahead, take that screenshot if you need to. But we're going to be talking about the 3 things here: distance, rate, and time. I'm going to show you what these look like, especially in word problems. That way we can point them out. Because the first thing in the word problem is being able to be confident in terms of what the heck you're actually looking at, right? A lot of the times we give up on word problems because we don't know what we're being asked to do. We don't know what's going on. And that's the first thing we're going to touch on. So distance equals rate times time. This is your formula. Write this down. Write that down right there, man. Let's go. So I'm going to zoom in now. Hopefully you've had the chance to take a screenshot. So I'm going to zoom in and really talk about these things. So distance equals rate times time. First, let's talk about distance. So remember, distance is the amount you're trying to accomplish. All right. Let me go ahead and make that very clear for us. Very, very clear for us. It's the amount that you're trying to accomplish. Okay. The amount you're trying to accomplish. A lot of the times you're going to see it as distance. You're going to see it as miles, feet, meters, inches, kilometers, whatever it is. But typically we see it in distance. But there's other amounts as well. Other amounts can look like dollars and other currencies that you're looking at. So someone who's trying to save up $500 or save up $800, we've seen problems like that. Next, amounts like weight or items or reading a certain number of pages. Yes or no? Have you seen a problem in the past where they tell you, oh yeah, you know, how many, or if Tom is reading 27 pages per day, how many days will it take him to read 500 pages? Yes or no? Have we seen that problem before?
Yes.
Yeah, I'm looking right here.
Yeah.
We have everybody typing in right here. If you're on the laptop, you'll see all the chat boxing on the left. If you're on the iPad, you might have to pull that up for yourself on the side. But yeah, almost everybody here has seen that type of problem. And I can tell you right now, the formula distance equals rate times time, it applies to that. It applies to that. It applies to savings with money. It applies to a lot of different things, and we're going to expose those ideas. So weight, items, reading a certain number of pages, all that good stuff. Next, this is the big one, rate. I'm going to show you exactly how to point out rates in problems, and it's going to be a lot more intuitive than you think. It's a lot simpler than you might think. But here's the thing. Anything that is considered a rate, long story short, all that is the speed or the pace that you're trying to accomplish that distance at. So let me give you an example. if we're talking about, let's go ahead and say, and I made that crooked. So my people with OCD, I'm sorry. All right, there. So let's go ahead and talk about, a car that's driving. If the car is trying to drive, let's go ahead and say 100 miles, what does the rate that they give you usually sound like, everybody? If you're trying to drive a certain number of miles, your rate or your speed is typically called what? Adam got it right there in the chat box. That's right, Risa. Doubled up right there. Aldine, correct. Miles per hour, right? Can we all agree on that? If we are trying to achieve 100 miles, a rate would typically look like, or your speed would usually look like miles per hour. Yeah, typically. Now, let me flip that over to money. Let's say it's a problem about saving money, saving $500. If you're trying to save $500, what that means is your rate or your speed that you're accomplishing that is going to look something like dollars per hour or dollars per day or dollars per week or a wage or a salary or something to that effect, right? They're always going to include that unit first. So if you're driving, going for miles, miles per hour. For saving money, typically dollars per hour. Reading number of pages, pages per minute or pages per day. And so I'm just trying to really wire your head here to really understand how to point out a rate. Because if we look at these examples, everybody, riddle me this. What do we notice? What do we notice that's pretty similar between miles per hour, dollars per hour, pages per minute, pounds per month, raindrops per second? What's the commonality between all of those different examples of rates, everybody?
Per.
And I'm looking at the chat box here. Do they agree? They absolutely do. They agree with Michael. Yeah. Yep. And we're not cats here. No, per as in P-E-R, not P-U-R. That's correct. Right here. Per. Right there. You can point out rates right there. The word per that connects two different units, typically the distance and the time. There it is. Rashid, do you have a question?
Oh, no, I didn't raise my hand or anything, right?
Oh, no worries. I just heard someone talk. No worries. I'll keep it muted there. So yeah, just make sure to keep yourselves muted. That way I don't think that you're trying to talk or anything. I gotcha. So yeah, it's really easy to point out when you look at it. The word per, it really gives it away. So we're going to talk about problems here. We're going to make this a lot of fun. I got you. But now we're going to look at time. Time, I think this is the easiest one to point out. I think for a lot of us, it's really easy to point out because time is just there. It's just the amount of time that it takes to accomplish that distance. Sometimes they'll say, oh, he drove 50 miles in 4 hours. Oh, 4 hours. There's my time right there. Or if they give you a certain number of days, minutes, seconds, hours, weeks, years, all of those are time. And I think we can all agree on that. That's not too hard. What is hard, though, is pointing out the rate and pointing out the distance. For a lot of people, these two things are really tough, and that's what we're going to work on today. All right. So get excited for that. But there it is. Take one more screenshot if you need to. Take a screenshot if you need to. Distance equals rate times time. Distance is literally how much you're trying to accomplish. It could be distance. It could be a number. It could be an amount of something. It could be anything. Rate is the speed at which you're trying to get there. So again, the word per really gives it away. Another phrase that gives it away is for every. So for every hour, Nate earns $30. That is a rate because you're saying for every hour, you get this. So we'll talk about those. We absolutely will. So yes or no, do we understand in principle what we're discussing here? Yes or no? The distance, rate, and time, how to identify them. Are we good so far?
Yes. Yep.
All right, perfect. Sounds good. And for those of you who are here for the first time, this is something that I do very, very frequently. I make sure that the beginning notes that we have are down to a T, because when we get into the tougher problems, these are the fundamentals you want to stick to. You absolutely want to stick to your fundamentals. This is how we get started. And so let's go ahead here, my party people. Let's talk about some warm-ups, man. So these are the more standard types of problems that you're going to see. These are the easier types that you're really going to see. So let's go ahead and really read this from start to finish. Now, I'm going to show you my three-step process for solving all work problems right here. I'm going to show you my three-step process. But first off, let me just read the question as if I had no training at all. My people that are in my all-access pass are going to hate me for this. But let's go. So a car travels at an average speed of 60 miles per hour for 9 hours. How far did the car travel? All right. So for all of my all-access folks, for people who know me, what did I do wrong?
Didn't read the
You
question.
didn't read the question first.
Didn't read the question.
That's right. I didn't read the question first. So for those of us that are here for the first time, this is something that I'm a stickler for. You always want to read the question first. Always, always, always. Reading the question first gives you the advantage of understanding what you're supposed to figure out first. Every single time. If you don't know what you're looking for, it's really hard to say that you know what you're doing if you have no idea what you're looking for. So you always want to start by reading the question here. So what is it that we want? And so right here, let me highlight that again. How far did the car travel? Everybody, if I had to circle one or two words, what should I circle here?
Per
Per.
and far.
No, in the red highlight,
Oh,
Travel.
travel.
I love this. I see in the comments here, right here, far, how far. Yep, it's how far. It is absolutely how far here. These are the key words or the key phrase that's really going to give it away. How far? So if you're thinking in practical terms, think about it, guys. I was like, think practically here. If you're thinking about this practically, and we're doing distance, rate, and time, when you say how far, are you thinking distance, rate, or time, everybody?
Distance.
Right. And you'd be right to say that. You'd absolutely be right to say that. It is distance. When you say how far, you think of distance. You think of, oh, how far? Or 20 feet, 5 miles, distance. That's absolutely distance. Cool. So what is it that we want? We want distance. That's what we want. We want distance. So write that out. Boom, right there. We're good. And so everybody, the distance that we want, what are the units for it? Is it feet? Is it yards? What is it?
House.
Ours.
Miles. Absolutely.
Miles.
And we see that right there. We want miles. Okay, cool. Sounds good. Now, let's go ahead and understand what we have. Okay? Because again, the first step is asking what you want. What information do you want to figure out? Now let's figure out what information do we have to work with. Let's look on our tool belt to understand what we can do. So let's read the problem again. Car travels at an average speed, hint, hint, 60 miles per hour. Everybody, this 60 miles per hour, what is that?
Distance. Rate. Distance.
Now if you're saying rate, what would give it away? What would give it away?
Per hour.
Per hour.
Yeah, that word right there, per. Right there, per. Remember that rate combines the distance and the time. Miles per hour connected by per. So that is a rate all day. That's a rate all day. Now, if we look at the last piece right here where it says 9 hours, what does 9 hours represent?
Time.
Time. So let me just make sure I write this again here. Per gives away. It's a giveaway that you're dealing with a rate. So a giveaway that you have a rate. Okay. And then over here in purple, that just says 9 hours. Again, seconds, minutes, hours, days, weeks, years, centuries, time. That's all time. That's all time. So we can write that down. And so I know a lot of people already asked in the chat box. I saw it already. A lot of us are saying, hey, don't we just multiply the 60 and the 9 to get the answer? Yeah, you're absolutely right. But here's how I teach. I want to make sure that you know why that you're doing that, because I don't want you to run into a situation where they literally switch up the problem ever so slightly, but you make the same assumption. Like, I want you to always know why every single time. And so with that said, take a look at this, everybody, or actually everybody in the chat box, help me out here. Write the formula. What formula are we dealing with today? And don't just use the letters, use the actual words. Type it out there. Everybody go ahead, type it out. I'm not moving on until at least 60 of us type it out. What's the formula? The whole formula. There we go, Antoinette. Thank you. Distance equals rate times time. Everybody, go ahead and type that thing in. Everybody, go ahead. Janice asks, so D equals RT is for hours, but there's another formula for minutes. Yes. No. So I'm going to help you out, Janice. I got you. That's a great question, actually. Someone will respond to that in a moment. I got you there. I like it. Everybody type it in there. Yep. Distance equals rate times time. Come on. Let's go. And remember that if you're not using the mic, just make sure to keep yourself muted. That way there's no feedback for the recording there. Perfect. All right. So Janice asked a great question here. Janice asked, hey, so look, for the formula, let me write it out here. So for distance equals rate times time, Janice asks, well, does this change if we're dealing with minutes or seconds or days? And the answer is no. You do want to make sure that your units line up, though. Let me show you how, everybody. So everybody, the time that we have, what are the units for time, everybody? What are the units?
Hours.
Right, the unit's hours. And I think we can all point that out. Now, let me point out something even more interesting. Everybody, the 60 that they give us here, that's miles per what? Miles per
Hour.
Hours.
do the units line up? Yes or no?
Yes.
They do.
Yes.
My rate is per hour. My time is hours. And so, Janice, to answer your question, all you need to do is make sure that the units line up. Has anyone here ever dealt with a problem where they said, hey, the car's driving 45 miles an hour? How far does the car go in 30 minutes? Anybody ever get a problem like that?
Yeah.
Yes.
Yeah. And so the formula doesn't change. You just need to make sure that the units are already lined up. That's what you got to make sure happens. That's it. So we'll talk about that if we see a problem like that in today's lesson. So yeah, just make sure that the units line up and you're good. So let's get to it, gang. Let's go. Let's not waste any more time here. We're looking for distance. Let me just keep that highlighted. I'm looking for that. So I'll just write D right there. Now, everybody, repeat after me. What is it? What's the rate? What rate do they give us?
60
60.
miles per hour.
That's right. They give me 60. And that's in miles per hour. That's right. And then they give me the time. What's the time, everybody?
9.
9. 9
That's
hours.
right. The time that they give us is 9 hours. And so we'll write that out there. And so to answer the question, yep, are we just going to multiply 60 and 9 together to get the distance?
Yes.
Absolutely. Yeah. We can see that now once we set up the formula. We're feeling pretty good about it. Yeah, 60 times 9 is the answer. Everybody, what's 60 times 9?
540.
540.
That is correct. 540 what, though?
Miles.
Miles per hour.
Miles.
Nope, just miles.
Oh.
Just miles, because distance is just miles here. Just miles. And you can tell with the answer choices, too. We just got miles all up in the answer choices, but the correct answer, nonetheless, is D. So,
Coach,
what's up, Jose? How we doing?
and how do you be sure that that is the answer? Because I know in some rate times that, I know in some problems you have to divide, am I right? In some problems, something like that?
Yeah, exactly. So in the coming examples, I'm going to show you exactly how to tell which way you're going with the formula.
Okay, thank you. I just want to be sure that I'm getting the right problem. That's it.
Yeah, you're good. And actually, I'll give you the note right here, everybody. So when it comes to distance, rate, and time problems, so write this down, everybody. So this is kind of like a shortcut way to put it, but I'm going to explain how this makes sense. So in distance equals rate times time problems, if you're looking for the distance, you're multiplying. Yeah, make sure you keep yourselves muted. So if you're looking for distance, you're going to multiply. You're going to multiply. If you're looking for anything else, you're going to divide. So if you're looking for anything else, you are going to divide. Absolutely. So we're going to go over this again. We're going to go over quite a few problems today. I'm going to show you when to do what, and I'm going to back this up. But long story short, if you're trying to get rate by itself or time by itself, notice that they're attached. So you're going to have to divide to get rid of what's attached to get that thing by itself. But when if you're looking for distance is already by itself. It's already by itself. All you have to do is multiply right there and you're good. All you got to do is multiply. So that's why that would make sense. But again, I'm going to show you all these different examples. So Alejandro asks, quick question. If the distance and time is given to us, but not the rate, you'll divide? Absolutely, Alejandro. Absolutely. So if you're looking for anything else, you will be dividing. Yeah. Cool, sweet. So again, we're going to be looking at these problems here. I'm going to show you this next problem here. So I'm going to show you exactly what we mean. So here we see that Jacob flew his plane 1,800 miles in 4 hours. And we're asking, what was Jacob's speed in miles per hour? Okay, cool. Sounds good. So let's go ahead and get to it then. Everybody, the first thing I need to ask myself is, what is it that I want? So everybody, what do I want? If I highlighted the problem here, what is it that you would say that we want?
The speed in miles per hour.
You want the speed in miles per hour. So what we want right here
Is the rate? Is it?
We want speed, and that speed is blank miles per hour. What kind of a unit would miles per hour be?
Right.
That's the rate. If we're thinking distance, rate, and time, that's going to be rate for sure. Because the dead giveaway, what word is it, everybody?
Miles per hour.
One word, one word. What one word gives it all away?
Per.
Per. That's right. Per. That is right. Right there. Per gives it away. I mean, he's a highlighter here to really make sure that makes sense. Again, that's the dead giveaway right there that you're dealing with a rate. So who here is feeling more confident with dealing or identifying rates now that you know that the word per is a giveaway?
Me?
Hey, that's what's up.
Me.
Again, little by little, we're going to get this down. So remember, I'm going to keep pointing out a bunch of little things. And once you really understand how all these little things make sense, that's when the big idea of really just takes care of itself. So keep asking these questions, keep being consistent with it, man. You got this. So there we are. We're looking for speed, miles per hour. And again, that's going to be a rate. Keep that in mind. So now we have to ask ourselves, what is it that we have? What do we have? What do we have? What do we have? This is the next necessary question. So you can figure out what the connection is between what you want and what you have. So let's get it, everybody. We have over here in blue, he flew his plane 1,800 miles.
Distance and the time.
That's what's up right there. So again, what do we have? We have 1,800 miles. That's the distance. That is great. And then we got 4 hours. What's 4 hours, everybody?
Time.
Right. That's just going to be time. That's going to be time. So right there. So when you write your information down, everybody, you check it out and you're like, oh, okay, I'm looking for my rate. I got my distance. I got my time. Everybody, can I just plug this into the formula and solve right now? Yes or no? Yes.
Yes.
Yeah, we can. We absolutely can. We're feeling pretty good about it, and we should. Let's go ahead and use our formula, and let's have ourselves a good time now. So here we go. Distance equals rate times time right here. So I'm going to plug everything in here. My rate is what I'm looking for. Everybody, give me a letter for rate. Be simple here.
R.
R for rate. Cool. That's what I'm looking for. Sounds good. Again, I try to keep things simple. You're looking for rate, use R. You're looking for penguins, use P. You're looking for cockroaches, use C. Like seriously, keep it simple. Try not to use X and really plain letters, just because you might forget what that actually represents. Be practical. So here we are. Cool. Plug everything in. My distance over here, that was 1,800 miles. All right, great. And then the time that I got, all right, cool. R times time. Time was given to me as 4 hours. So is it cool, Cho, if I literally just rewrite this as 1,800 equals 4R? Y'all cool with that?
Yes.
Yes.
Cool. And now all that's left to do, everybody, be specific. What do we have to do? Be specific.
Divide.
Both sides by 4. Both sides by 4.
I've been teaching y'all well. Yep. We want to do the opposite to get the rate by itself. And so right now what we see is that the rate is being multiplied by 4. So we need to do the opposite of multiplying by 4, which is dividing by 4. But you need to make sure that with an equation, remember that we're trying to keep it balanced. Equations are literally statements of balance. And so to keep it balanced, you got to do the same thing to both sides. So we're going to divide both sides by 4. By 4 right there and 4 right there. And then we are good. So on the right side cancels out. We get left with R. And then we're going to do 1,800 divided by 4. Who here looks at 1,800 divided by 4 and feel like they might do it by hand? Who needs to do that by hand?
Me.
And be honest. Yeah, be honest.
Just do it.
Yeah, I'm good with
All right. So
What's
I
that?
love it when I do this here. So I'm going to show y'all exactly how to use mental math in the way that really works for you. So everybody, true or false? True or false? 4 is the same thing as 2 times 2.
Yes.
True.
Yes.
All right, just hitting you with some simple facts there. I think that can be agreeable, right? 4 is 2 times 2. So is it fair to say that if I'm dividing by 4, that I can instead just divide by 2 and then by 2 again?
Yes.
Yes.
You can actually do that. You can actually do that. And so I got to make sure I mute everybody because I do know that a lot of people here are having a hard time keeping themselves muted. So I'll go ahead and do that for you. So if we're dividing by 4, long story short, just divide by 2, then divide by 2 again. That's really what you can do to divide by 4. It's the same idea. So everybody watch this. Let me bring it off to the side over here. Because you don't get a calculator on the ASVAB, so let's be real here. If I want to divide by 4, I can just divide by 2, then by 2 again. Everybody, what's 1,800 divided by 2? Right? I think we all know that. We may not know what 1,800 divided by 4 is, but I know that we know that 1,800 divided by 2 is going to be 900. And I still got to divide by 2 because I only divided by the first 2. Everybody, what is 900 divided by 2? That's a lot easier, right? That's a lot easier to see. And so again, what had happened was we divided by 2 on the top and the bottom. Now we have 900 divided by 2. We're going to divide by 2 on the top and the bottom again. And we end up getting 450 over 1, which is the same thing as 450. Just a little way to use mental math. If I'm dividing by 4, I can just divide by 2 and then 2 again. If I'm dividing by 10, I can divide by 5, then by 2. It works. It absolutely works. If I'm trying to divide by 9, I can divide by 3, then by 3 again. That's what mental math really is. It's just breaking down one big step into smaller, simpler steps. That's really all it's about. And so in case anybody didn't know that, hopefully that does help you in a positive way. But the answer here is 450 for the rate. But help me out, everybody. 450 what? 450 what? What are the units here? What are we dealing with? That's right, Risa, miles per hour. And I'll go back to that in a moment here. I got y'all. Miles per hour. Absolutely. So that would be the answer here. That would be B. But let me go ahead and go back into the part here for that mental math. I got y'all. In 2 seconds, let me just fix something that's in my background because I do have a little. There we go. Got a little white thing in the background to cover up the slide number, but there we go. So let me go ahead and go back here and really help us out. So if we're looking at 1,800 divided by 4. So remember, all I said was, hey, 4 is the same thing as 2 times 2. So if I'm dividing by 4, I can just go ahead, divide by 2, 2 times. So divide by 2, then divide by 2. So I'm playing off of the way fractions work. Whatever I do to the top, I gotta do to the bottom. So if I divide the top and the bottom by 2, 1,800 divided by 2, or 18 divided by 2 is 9. 18 divided by 2 is 9. So 1,800 divided by 2, 900. Give me 2 seconds here. Let me go ahead and decline that. All right. So there's that. Oh, Lordy. 2 seconds, everybody. Some people don't check their emails and then they want to hit me up at the last second here. And I get it. It's all good. But there it is. If I take 1,800 divided by 2, I'm gonna get 900. I still have another 2 to divide by. And so I'll go ahead and do 900 divided by 2. And that's what's gonna give me, boom, 450. So again, that was just a little mental math thing. If you want to keep doing long division for right now, totally fine. Just know that if you want to be quick on the ASVAB, you're going to have to start teetering in the range of that mental math. All right. So with that said, again, all I did was instead of dividing by 4 immediately, I divided by 2 twice. That's all I'm saying there. All right. So don't get too worried about this part. Don't worry about that too much. Again, today's lesson is about distance, rate, and time problems and pointing out those little things. But I'm hoping that for us, we have learned the difference at this point in terms of when we multiply and when we divide. Do we have a better understanding of when we multiply and when we divide with distance, rate, time problems? Yes or no? Ooh, I like that chat box. Hey, there we go. Again, if we're looking for distance, multiplying, because distance is already by itself in the formula. Everything else multiplies to get the distance. If we're trying to get anything else, we divide. All right. And so I'm going to show you again that if you just learn how to set up the formula the right way, you'll automatically see what you need to do anyway. I'll show you that. All right. So with that said, let's go ahead and tackle another guided warm-up problem here. So let me show you here how, again, distance isn't always distance. I'm going to show you that right now. But oh, so Jeremy, great question. What do you do when you have the distance and the time twice in a problem? So we're actually gonna talk about those problems today. I got you. Don't worry, we're good. And so here we go. Everybody, what's the first thing I should do in this question? Let me give you all the mic here. What's the first thing that I should do?
Read the question.
The question.
Read the question. Let's go. Read the question. And so everybody, what's the question ask us to look for?
Minutes.
Speed per minute.
I don't know. Let's go ahead and highlight that question. Let's help ourselves out real quick.
Time.
It asks,
How many minutes?
how many minutes did Adam run for? Shout out Adam Sheely. So how many minutes did Adam run for? So what should we be highlighting here?
How many
How many and then what?
minutes?
Minutes. We're looking for the number of minutes. That's what we want. That's what we want to find. Remember, what you want is always in the question sentence. Always go to the question sentence to figure out what you want. All right. And so we're looking at that and we're saying, hey, what do we want? We want minutes. But everybody, minutes is what kind of a unit?
Time. Or
Time. Minutes is time. That's right. If it's just seconds by itself, minutes by itself, hours by itself, days by itself, always time, always, 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 always. And so that's what we want. Now let's take a look at what information we have. Here we go. Again, what information do we have? What information do we have? And so we see here, Adam ran 22 laps. Okay, so if I write down 22 laps, this might be confusing for some of us, but what does 22 laps represent?
Rate.
Now, for
I mean,
a rate, what
distance.
do we typically see if we want to call it a rate?
Distance. Per.
Is distance.
Oh.
Exactly, because we usually see the word per for distance or for rates, that can't be a rate. That's just 22 laps. Like it's just laps by itself. It's just laps. If we wanted the rate, it would have to be something per minute, something per second, something per hour, right? It has to be something like that. But we don't see that here. We just see 22 laps. So yes or no, my party people, can we understand that because it's just laps, that's a distance?
Yes.
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 Cool. I'm really seeing a lot of us starting to clear up those misconceptions. Because I know a lot of us, like when we just start out, we get a little nervous and we'll see whatever number and we'll be like, that's a rate. That's this, that's that. And you just hope for the best. Trust me, I've been there before. And we don't have to work that way when we know what to look for, when we're trained on what to look for. So again, if you're looking at a rate, typically it's going to say per hour, per this, per that, but we don't see that. 22 laps, if you're asking yourself, is that what Adam tried to accomplish? Yes, that's what he accomplished. That's how far he went. That's distance. because that's how far he went. Now we see next over here, it says average speed of 4.4 laps per minute.
That's the rate.
That's the rate. There's two words that give it away that it's the rate, everybody. What's the first word that gives it away?
Per.
Per. That's our primary keyword there. Per absolutely gives it away. Absolutely. Now, what other keyword gives it away and what I highlighted?
Speed.
Minute.
Speed. Speed right there. Speed and rate are synonymous, everybody. Synonymous means the same thing. Speed and rate are the same thing. Speed and rate tell you how quickly you're moving, how quickly you're getting to what you're getting to. Whether it's laps, pages that you're reading, whatever it is, rate is telling you how quickly you're doing that thing, how quickly it's happening. And so there it is. Booyah, we got it. Let's write it down. So we got 4.4 laps per minute. And so that's going to be my rate. Now, everybody, let me point something out in terms of the units that we were talking about earlier. So Janice, kind of following up on your question here with the units here. So if you look at this, everybody, we're looking for minutes. That's the time. And our distance is laps. The rate that we're going to be using is always going to be distance per time. Laps per minute. Is this starting to make a little more sense to anybody here? The
Yeah.
rate,
Yes.
laps, the distance per the time. Laps per minute. Right there. But it just takes time to see. But once you actually see it, like this is going to be really, really manageable, man. I'm telling you, it's really manageable. So here we are. Let's go ahead and set ourselves up nicely here. We got D equals R times time. Cool. Everybody, what letter do I want to use for minutes here?
M.
Thank you for being practical. That's right. It's M.
Oh, and
Sounds good. And as a reminder, everybody, make sure to keep yourself muted unless you are ready to speak, because I see here that we got like 8 mics on, but there it is. Yeah. So we're going to keep the minutes as M. So I'm just going to put that M right there. Everybody, what is my R going to be?
R 4.4.
Correcto mundo, 4.4. So we got 4.4 times M, or 4.4 M, whatever way you want to say it. And then what are we going to use for that distance, everybody?
22.
22.
22. There we go, 22. And there we have it. And there we have it. And so with that said, what are we going to have to do to solve this problem? Because remember, the goal here is to get M by itself. So what do we got to do here, everybody?
Divide it.
Divide what?
4.4 divided by 22.
22.
Not
On
satisfactory.
both sides.
There we go. Divide the 4.4 on both sides. I know I'm going to be annoying. I know I'm going to sound annoying with this, but we have to do here, everybody. What we have to do is make sure that we can talk about what we're doing. So right now, what we have to do here is divide both sides by 4.4. So once we do that, booyah, cancels out on the right. And so we're going to have the M by itself like we wanted. And now we have to figure out what 22 divided by 4.4 is going to be. So here's one way that we can work on this, everybody. One way that we can work on this is really just ask ourselves, what can go into both 22 and 44? Notice I'm not saying 4.4. I'm saying 44. Because with the decimal, you can ignore it and then bring it back if you want to. Honestly, you're perfectly allowed to. So everybody, what can go into both 22 and 44?
2.
2.
What else? What's a bigger number? Think about the biggest number that can go into
11.
both.
8.
Exactly.
So if I'm thinking of 22 divided by 44, what goes into both 22 and 44?
11.
11 is absolutely a number. Is there a bigger number though?
12. No, sorry. Wrong.
30.
2.
1.1.
Can 22 go into 44?
22.
Oh, yes.
Yeah, 22 can go into 44, man. Yeah, absolutely. Absolutely. Absolutely.
22 is 5.
And so we can divide 22 and 44, both of them, divide them both. They can both be divided by 22. Absolutely. But here's the only problem. The only problem is that we have a decimal place right there. That is really the only problem. And here's a secret that you may not have known about math. If you're doing 22 divided by 4.4, everybody, if I wanted to move this decimal place over to the right one time, what do I have to do with this decimal place over there for the 22?
Gotta move that
Move it over too.
Right. Remember, with fractions, whatever you do to the top, you do to the bottom, right? So that's what we're going to do. So instead of making it 22 divided by 4.4, this can turn into 220 divided by 44. If you want to do it like that in your head. If you want to do it like that in your head. Because if you do it like this in your head, then you can go ahead, divide both 220 and 44. You can divide them both by 22. Everybody help me out. How many times does 22 go into 220? I think this was a pretty easy one.
10 times.
10 times. Think about it. If you're looking at a number that just has a 0 in front of it, that's 10. That is 10. And then over here, what's 44 divided by 22?
2.
Okay. Everybody, what's 10 divided by 2?
5.
5.
Answer's 5. Answer's 5. Answer's 5. Now, we can do this the regular old way if we wanted to. We can absolutely say, hey, how many times does 4.4 go into 22? And we can go about it that way there. And we can do our work. But at the end of the day, you're still going to get 5. Still going to get 5. Because you're still going to have to take a guess as to how many times 4.4 goes into 22. You're going to have to multiply, do a little bit of trial and error. But if you understand how to manipulate decimals a little bit, so again, this is me telling you mental math works. Even if you don't see it right now, it gives you the ability to look at something like 22 divided by 4.4 and not stress about it so much. Because you'll be able to look at that and just say, no, that's the same thing as 220 divided by 44. Just move the decimals. And then from there, simplify. If you saw that it was 22, sure, great. You could have noticed that 11 goes in there as well. Could have noticed that 2 goes in there. You could have been noticing that really any other combination would have worked. But long story short, again, we're not here to focus too much on the mental math side of things. We are here to focus on the distance, rate, and time aspect, which again was focusing on knowing when to divide and multiply here. And that's how we got 5 for the answer. 5 what though?
Per minute.
Not per minute.
Minute.
It's just going to be
minutes.
Yeah, just minutes. Exactly. Yeah, just minutes. Just minutes. Just minutes. And so, boom. Right there. Answer is B, 5. But let's again talk about what we saw here. Here, we were able to identify what we were looking for. You got to do that from the very beginning here. Identify what you're looking for. Then from there, write down what you have. And I want everybody to write that down again and again and again. Right here. If you are even half afraid of word problems, like this right here is what you need to follow to a T. Gotta follow it. First thing you want to do is ask yourself, what is it that you want? Then work to understand what you have. And then once you have that, what connection is there? Here, we're able to see that it's distance, rate, and time. But what if it was a proportion? You know, what if we were dealing with any other type of problem, whether it's fractions, decimals, whatever it is? You got to be able to point those things out. But you can't do that if you don't start with these steps. Step number 1, again, ask what you want. Write that down. Typically give a letter for what you're trying to find, right? Then number 2, write down what you have and build your connection from there. Then build your connection. It's all good, Junior. I'll post the recordings onto the website. So if you're in the All-Access Pass, I'll send you the email when the recording's up. So if you divide by 2 twice, you would get 11 divided by 20 or 2.2. Then dividing by 2 again, it would take a little longer, but that would work. Cool. So let's go ahead and let's talk about a test level question here. So if you are here looking for, before I even begin, Stephanie, what's up?
Oh, okay. So why did you take, I had everything, like, I understand what you're saying, but why did you take the decimal out of the 4.4?
Because it would work a little different if you tried to divide 4.4 by 22. Doing that straight up would make it look like 0.2. And you would have to know that when you flip that, that becomes a 5. So I didn't want to go through all of that confusion. Instead, I first looked at it like this. So let me just go ahead and erase this again here. I got you. So let me just erase all that, all that, all that. All right. So if you're looking at this, 22 divided by 4.4, the reason I moved it to a decimal place to the right is because it's a lot easier to deal with whole numbers and not decimals when it comes to division. So if you look right here, I went ahead and said, hey, if I move this over to the right one time, I just got to move this over to the right one time, because now it becomes 220 divided by 44. So Stephanie, is it agreeable to say that it's easier to divide when you have whole numbers?
Yeah, for sure.
Yeah, and so that's why I did it. I did that because it gives me whole numbers to work with, 220 and 44, and from there I can divide mentally in my head. I know that
Gotcha.
22 goes into both of them. I do my work, and there it is.
Okay, thank you.
Yeah, no worries. Good question. Great question.
Coach.
Yo, yeah, if a lot of us are worried about the calculations, I got you with the mental math. First of all, download the app and then start watching these YouTube videos that I'm putting out and in the math bootcamp that are coming out shortly, for sure.
Coach,
What's up, Jose?
to be sure, the distance is always going to go inside when you divide, or would there ever be a situation where you have to bring it out, or it's always going to be inside when you always divide?
No, so when you look at the formula itself, D equals RT, just take a look at the formula. Is there any division going on with the distance formula or with distance itself?
No.
Nope. It's just by itself. And the way that you get distance, notice that you are always multiplying the rate and the time together. Always.
What's the app? Oh.
Always. All right. Always, always,
What's
always.
the app? What's the app that you said to download?
I got you, Michael. Remind me at the end of the class. I'll make sure that everybody gets a chance to download it. I got you.
All right, cool. Thank you.
Yeah, no worries. So Jose, let me know if that made sense.
Yeah, just always look at the formula.
For sure. Gotta set it up the right way. So let's go ahead and get into it here, man. So this is a test level question here. So remember when I talked earlier about a question where, if you got like two objects going in the same direction or opposite direction, we talked about that. And a lot of us were able to recognize a problem like that. Now, obviously, this is still a warm up here. I'm still guiding you through this. But here's one of those situations where I want to show you how hard it can be if you're not quite understanding of how the pieces work. So again, everybody, let me warn you right now, this is a slightly more complicated question. We're dealing with more pieces, but I'm going to show you exactly how to handle these pieces, okay? There's two rates here. I'm going to give everybody here a minute and a half to answer the question. Again, we're not asking for any numbers right now. We're just asking for what we should be doing with the two rates that we see. So don't give away your answer. I'm going to give away right here a minute and a half, starting now. Read the question fully, the problem, the situation, and give your guess as to what should be done. And I want you to try to think about a reason why. Like, think about why you think that would make sense. So here's a minute and a half. Go ahead. Timer is starting. And don't reveal your answer. I'm going to mute everybody as well. So don't reveal your answer. We'll be back in about a minute. Go. I'll be right back. And time. Let's go. What do we got, gang? Type those answers in. What do we have? And give a reason if you have it. Give a reason of why you think you're doing what you're doing here. So going down this list here, I got some add them, subtract them, add them, add both rates. Okay, I see the actions here. Ooh, Joe Marie, I see you picking up those notes there. Opposite directions means add the rates. Okay. See some more guesses here. A, C's, and D's. Subtracts. B, this one's hard. Add them. All right, cool. So far, so good with the guesses. I see only about like 20, 30 people there, but that's all good. So here's the answer, everybody. Let me tell you what the answer is. The answer is going to be A. It's going to be A. You're going to be adding the rates. So let's go ahead and highlight that real quick. So let me go ahead and show you why, okay? So let's go through the problem here. Let me show you why. I got you. So first things first, everybody. What is it that we are looking for? So what is it that we want here, everybody? Go ahead and use that chat box there. I'm going to give you all the mic in a moment, but go ahead and use that chat box. We want, I see some people saying distance, some people saying time, speed. What is it that we're looking for, though? Look at the red highlight. How long will it be until the cars are 150 miles apart? There we go. Time. Yep, that's what we're looking for here. How long will it be? So whenever you read that phrase, everybody, think about it. When you're thinking about it, it's like, okay, how long will something take? Well, when you're asking how long will something take, that's time. It could take 5 seconds, could take 3 hours, who knows? But we're looking at time. So what we want is definitely time. Now let's ask ourselves, hey, what is it that we have? Because this 150 miles apart, that's important information for sure, but it is not what we're asked to find. That is information that will help us get what we're looking for, but it's not exactly what we need to find. It's actually just plainly given to us right there. So let's go ahead and highlight that in blue. So what we have, everybody, is 150 miles. Everybody, what kind of a unit is that? What kind of a unit is that? Let me give you all the mic here. 150 miles.
Distance.
Yeah, that's distance because it's just miles, right? It's just miles. If it's just miles, then that's definitely a distance and we're good. Somebody write that out right there. So follow along here, gang. Follow along. I got you. Yeah, I got you. Yeah. Just miles, right? Just miles, that's distance. Now, this is where things get confusing. So put your pencils down for a quick hot second. I'll let you take a screenshot for sure, but let me show you exactly what's going on here. So if I look at the problem, I'm gonna use green to highlight the new information. 2 cars start in the same spot and driving away from each other in opposite directions. So 2 cars. So here we're dealing with 2 different objects. Okay. Then we see the key phrase here, opposite directions. So let me go ahead here and illustrate the point for us. On one hand, I'm going to say in purple, the first car, 25 miles per hour. The second car, I'll go ahead and use a different highlighter here. I'll go ahead and use this royal blue over here. Other car, 35 miles per hour. So let me go ahead and express this point. If I'm taking a look here and they're going in opposite directions, let me go ahead and just illustrate the point here. Watch this. So going to the left, we see 25 miles per hour. Then if we go to the right over here, let me go ahead and take this over here and make that the blue I was dealing with earlier. And that's 35 miles per hour. Everybody, just illustrate this for yourselves. Like, just think about this here. If you take a look there, okay, we're going that way 25 miles an hour, and we're going 35 miles per hour that way. Everybody ask yourself this very, very straightforward question. Does it look like, as time passes, does it look like the cars are getting further apart or closer together?
Further.
Right. They're getting further apart. If we just ask ourselves honestly, like intuitively, genuinely, like what's happening? Are they getting further apart or getting closer together? Because if it looks like they're getting further apart, what that means is this distance and this distance, we add them together to find out how far it actually is. Again, if you take a look here, let me go ahead and highlight this for you. The distance from here to here. So again, however much time we're talking about doesn't really matter. This is how far the purple car or car A goes. Then if we look at the other way around, this car is going this way. It's going the opposite direction. They're going the opposite direction. And so when you ask yourself, yo, what's the total distance? The 150 miles. Just take a look, everybody. We take this entire section and we add it with this entire section. Everybody, do you agree with or disagree with me? To get that 150 miles, you add how far this car went with how far that car went.
Agree.
Perfect. And so if you're adding the distances, that means you're adding the rates. Because if you're basically getting the total distance by adding this car, how far it went, and that car, how far it went, then the distance, how it got there, is the rates added together. That's really what it is. Another easy example that I can use, everybody, another easy example I can use is I can say, hey, look, let's say I got these two people here. One person's walking this way, other person's walking that way. Okay. So if I just put them over each other so you can actually see them, if this person takes one step every time I go beep, and this person takes 2 steps every time I go beep, think about it like this. After one beep, how far apart are they? Beep, 1 step, 1 step, 1 step. How far apart are they now?
1 step apart.
How many total steps apart are they?
Oh, 3.
3, right? Because if one goes 1 this way and this one goes 1, 2, if you add the total together, that's 1, 2, 3. 3
I
total.
get it.
And so when you look at their rates over here, if this one's going 25 miles per hour this way, and this one's going 35 miles per hour that way, the true rate is going to be 25 plus 35, adding them together. And so everybody, what's 25 plus 35 added together?
60.
60. That's right. And so the true rate here is equal to 25 miles per hour plus 35 miles per hour. And I'm going to give you the key here. I'm going to give you the handy way to think about it. But the true rate for both of the cars together is 60 miles per hour. And so let me go ahead and write this down for you. Let me write the rule down for you before we actually get to solving this problem. So here's the rule. And again, this is specifically for you when you're dealing with 2 objects in the same scenario, okay? So 2 objects, 2 objects right over here in the same scenario, same situation. So if they're going opposite directions, you will add the rates, okay? Opposite direction. Opposite direction, we're going to add the rates. Now, if they're going the same direction, what do we do?
Subtract.
That's right. We will subtract the rates. We will subtract those rates. So write that down, everybody. Write that down, because we're going to get into some of these problems here, and they can seem intimidating at first, but once we, again, apply these rules and apply our intuition here and actually like play out in our heads how this works, you're going to see that this is, again, really, really, really doable. So, no, Shahid, no, it will not be 60, because the question that we're being asked is, how long will it be until the cars are 150 miles apart? So we're looking for time. So remember, we're looking for time. Notice that we have the distance and we had two rates. We had two rates. So now we need to go ahead and figure out what the true rate is. Because remember, everybody, how many times does the letter R appear in distance equals rate times time? If you think about it, D equals RT. How many rates are in that formula?
One.
Just one rate. So if you see a word problem that has two rates, is that a problem?
Yes.
Yeah, definitely an issue. Definitely an issue that we want to take care of, right? We got to take care of that. And so in this specific instance, because these cars are driving away from each other in opposite directions, how far this car goes and how far that car goes, they add up together to get that 150 miles. And so we have to add the rates to get there as well. And that's what we have to do here in this situation. And so once we have that, we're going to plug everything in. And so everybody, what distance were we given again?
150.
That's correct. We were given 150. All right. And then what was the rate that we now have, everybody?
60.
Woo, I love the quickness there. Yep. 60 miles an hour for that rate there for sure. And then the time, that's what we're looking for. I'll just keep it as T. T for time, whatever. And so we got 60 times T equals 150. And so what are we going to do now, everybody? Since we're looking for time, our rules say that we will be doing what? Multiplying or dividing?
Dividing.
Divide.
We're going to be dividing here. That's right. We're going to be dividing, and we will divide both sides by what?
60.
60.
Correct. There we have it. And so we'll cross that out on the right side here. Now we have 150 divided by 6. You can go ahead and use your calculator, or not calculators, but use long division if you need to. I would suggest simplifying it before you do that, because everybody, what can you cross out of both 150 and 60?
0.
0.
Yeah, you can cross the 0 out for sure. So bam, bye. So now that's the same thing as saying 15 divided by 6. And so if you want to just go ahead and try to divide 6 into 15, again, do your thing. You can use mental math to say, okay, 6, 12, so that's 2. 12 to 15 is 3. So 3 out of 6 is the same thing as half, 2.5. You can say it that way if you'd like to, or again, you can just go ahead and just do how you trust it. 6 goes into 15 2 times. Subtract the 12, you get 3 left. Put a decimal place. Bring down the 0. Everybody, 6 goes into 30 how many times?
5.
5 times. That's correct. And so we have 2.5 as our answer. So either way, you can do it with mental math, or you can use long division. I'm not here to tell you either way, just here to expose some things that you can do to make your life easier. So the 2.5 there, 2.5 what?
Hours.
Ooh, right on. 2.5 hours. That's how long it'll take to get 150 miles apart.
So I have a question.
Yeah, for sure. What's up?
Yeah, like the answer, if you have options, and then like you have like 2.5 hours, and then another option that you have 2 hours 30 minutes. How are you going to?
Thing. So yeah, those are the same exact thing. And on the test, they will not give you 2 correct answers. So if you see 2.5 hours or 2 hours 30 minutes, I would circle either one of those. Yeah.
Oh, okay. Thank you.
Yeah, I got you. So what happens to the zeros in the answer? Karen, I got you. So are you talking right here? Yeah. So basically with 150 and 60, in case you didn't know this, whenever you have a number that ends in a 0, so like 150 or 110 or 90 or 60 or 50 or whatever, it can be divided by 10. And so when you divide by 10, you're basically just getting rid of the 0. So I divided both the top and the bottom by 10. And that's why I'm allowed to cross away that 0. So 150 divided by 60, same thing as 15 divided by 6. Nope, not necessary, Karen. Yeah, 2.5 is the same thing as 2.50, same thing as 2.500. Yeah, same thing. So you can just say 2.5 hours, but if one of the answers read 2 hours, 30 minutes, that would also be correct. Absolutely. Absolutely, my party people. Absolutely. Boom. So I'll let you guys take a quick screenshot of this one for sure. Please take a quick screenshot of that. So again, opposite directions, we're adding the rates. Same direction, we are subtracting the rates for sure. They don't. No, every question has one correct answer, Joshua. Every question has one correct answer. They may be giving you additional steps to convert for sure. That happens all the time, but they're never trying to trick you. I wouldn't say that they're trying to trick you. They may just be giving you one more step that people just don't look at. So let's go ahead and talk about this. So yes or no, do you feel like you've gotten a better of an edge here in terms of understanding these rate problems? Yes or no?
Yes.
Yes.
Okay. Let's go and put that to the test here. Okay, let's go and put this to the test. So I'm going to give you this problem here. So, well, this is the same exact problem actually, but I want to go ahead and just really review the question again before I put you into practice on your own. Because again, this is going to be eye-opening because I'm going to show you different situations. I don't ever want you to assume that the same thing that worked in the last problem is going to work in this problem. So again, we already did this question and we got 2.5 hours. But remember what gave it away was that opposite directions, and they give you two rates. Two rates with opposite directions, add them. Two rates, same direction, subtract them. Every time, okay? Every single time. So with that said, my party people, remember, focus on the proper setup. I'm going to give you hints. I'm going to walk you through this. I got you. The second minute, remember that we're focusing on the calculation, but I'm going to give you 3 total minutes here. So honestly, you can focus the first 2 minutes on just trying to set it up. And again, I will be assisting. I will be giving hints. Let me go and mute y'all now. There we go. All right. So I'm going to give y'all hints for sure. I'm going to work through this with you. I want you to succeed here, but just remember this. We are looking to get the setup correct first. Don't worry about all the calculations and the decimals and all that hoo-ha. I really want you to focus on the setup. That's where the success is going to come. So starting off with the first question here, there it is. And I'm going to give you a timer right here for 3 minutes starting now. Do not reveal your answer. Just type ready when you're ready. After about a minute, I will give you hints. Start with the question. All right, we still got 2 minutes left here. Still got 2 minutes left. Let me go and point some things out here. All right, we got about 20 seconds here, so I'll let the rest of it play out. Hey, that's what's up, Eugene. Yeah, for those of you guys that stuck through it from the very beginning of class, like this is how it gets done, man. This is how it gets done. By practicing and doing your best. So 3, 2, 1, take a guess here. If you need to take a guess, put the answer in. If you want to get, go ahead. Get it. Let's get it. Come on. All right, sounds good. So even if you don't have a confident answer, do you have a solid setup? Were you able to identify what you needed to do with the rates? All right, I see y'all. Okay, that's what's up. So I'm gonna go ahead and give y'all the ability to unmute yourselves. But yeah, so I think we can see it pretty clearly now that if we look at the problem, let me start from the beginning here. The goal is to figure out how long will it take. So how long something will take. Now, everybody type it out, shout it out. When you ask, how long is this gonna take? What are you asking about?
Time.
For sure. We're asking about time. If I'm saying, hey, how long is this going to take? How long until my food is ready? How long until mom gets here? How long until this happens? Time. How long? Time. And so we're looking for time. Now, when we ask ourselves, what do we have? Well, when you read the story, when you're trying to get into the story here, you see, hey, we're talking about 2 cars, 2 objects. And you see that one's going 25 miles an hour this way. One's going 15 miles an hour in the opposite direction. So because we're going this way and this way, the distance they are apart is this distance plus this distance to get the whole 120. Opposite directions means what with the rates?
Add.
Add, that's right. Opposite directions means add the rates. And so now that we have that, booyah, we can go ahead and add the rates just like we know we need to do. It means add the rates. So everybody help me out. If we take 25 plus 15, what do we get?
40.
All right, way too many different answers here.
40.
Okay, cool.
40.
I heard 30, 40, and 50. I was like, oh, bruh. No, 40. And if we need a little help there, I got you. So here's a nice little mental math technique that I use. It's called split and glue. Literally all you need to do here, add 2 small numbers instead of the big number. If I'm adding 15, add 10, then add 5. Or add 5, then 10, because that's the same thing as adding 15. So just splitting it into the tens place and the ones place, and then bring it back. So 25 plus 10, 35, add the 5 again, 40. So as a reminder, my party people, make sure you keep yourselves muted. That way I don't get any background noise. Booyah there. Cool. So with that said, my party people, there it is. And so that's going to give us 40 miles per hour for the true rate. Right there. So we got that going on. We got our true rate. We got the distance that we're trying to get to, 120 miles. So that's the distance right there. And so we got to ask ourselves, like, how do we set this up properly? Cool. So we're going to see that we got distance equals rate times time. My distance is going to be 120 miles. Then we have my rate, which is now going to be 40 miles an hour right there. And then what am I going to use for time? Give me an easy letter that's probably already there.
T.
And so everybody, now that we have this going on, what do we need to do to both sides to get this done?
Divide 40 on both sides.
Divide.
Yeah, divide 40 on both sides. That's right.
And get rid of the 0.
Boom. Now that we do that, cross that out on the right side. T equals what, my party people?
3.
3.
3 what?
3 hours.
That's right, Morris. 3 hours right there, boss. Yep. 3 hours. 3 hours. 3 hours. So, like I said, my party people, whether you got it right or wrong, do you feel like you learned a little something about this problem?
Yes.
right? Like this is definitely doable, right? Definitely doable. You just got to make it through those crappy beginning parts for sure. You just got to make it through those crappy beginning parts. Run it louder, Linda. There we go, man. All right, so let's go ahead and dive into another one here. I'm going to give you all the whole 3 minutes again, and then I'm going to go ahead and show you how to do it. So I'm going to give you the 3 minutes. I'm going to let you know when you have 1 minute left. And after about a minute, minute and a half, I'm going to start dropping some hints. Okay. Was that enough? Like, was that good for y'all? Like me dropping the hints after a minute to give you all the chance to start it off?
Yes.
Yes.
Cool. All right. Sounds good. So let's go. 3, 2, 1. 3 minutes. Let me meet y'all right now. And let's go. I'm going to drop some hints now. Going to drop some hints. Remember, first thing you want to do. What do you want? Start with the question. All right, so we got about 4, 3, 2, and 1. Give it your guess if you got one. Go ahead, go ahead, go ahead, my party people. Let's get it. Let's get it. Let's get it. Come on. All right, sounds good. Looks like we're getting real excited there. All right, cool. No worries. Let's go ahead and check it out here, my party people. Let's check it out, man. So I went ahead and started off with the information there. So let me go ahead and just make this make a lot of sense for us. So first off, again, what is it that we want? What are we looking for? What do we need to be successful here? We need to figure out how long it's going to take, right? How long it's going to take. We look at the answer choices too. The answers just say hours. That's time. So even if you didn't know from the question, you can typically tell from the answers too what unit you're looking for. You're looking for time. You see hours there. Cool. That's what we want. Now, let's talk about what is it that we have. So what we have here in the problem, it says 2 cars, same spot, they travel in the same direction. 1 car goes 27 miles an hour. That's a rate because of the word per, right? 27 miles per hour. So per gives it away. That's a rate. But the problem also tells you the other car is traveling 42 miles an hour. what? We got two rates. This is a little confusing. We're looking at this and we're saying, what the heck? My distance rate time formula only has one rate, but I got two rates in this problem here. What do I do? So let me show you why we're subtracting. Because again, I gave you the rule, but I wouldn't be a good teacher if I didn't actually show you why this works. So I'm going to go ahead and give you all the mic just in case you have any questions on this. But what you need to do here is actually, again, subtract the rates. But let me show you again why. So let me do a little detour over here. So let me go ahead and find someone in the chat here. Let me go ahead and, hey, Michael, your Michael or mic working?
Yeah. Yes.
All right, cool. So I'm going to use Michael as an example, and I'm going to use, all right, so yeah, I'm going to say Michael, and Michael, everybody, let's go ahead and say that Michael has a crazy ex-partner. Let's say a crazy ex-girlfriend, if that's okay with you, okay?
That's fine.
All right, cool. So let's say Michael has a crazy ex-girlfriend, man, all right? So let's go ahead and say we're right here, right? Let's go ahead and say that this right here is Michael. Let's say that's Michael. And we're going to use C right here for crazy X, okay? All right, so let me show you why we're subtracting the rates. Let's go ahead and say that for every minute or every hour or whatever, Michael goes, let's go ahead and say, he goes 7 miles per hour. He is running, he's zooming out of there. He's going 7 miles an hour that way, okay? Now, let's say his crazy X can run at a speed of, let's say, 5 miles an hour. So everybody, watch this. If Michael every hour goes 7 miles, he can run 7 miles. His crazy X is like, hell no, you ain't getting away from me. I'm going 5 miles an hour. Let's ask ourselves, everybody, after 1 hour, how far away is Michael from his X?
2 hours. 2 hours.
2, right?
What?
Yeah, it would be 2, but let me show you why. Because if I take, watch this, everybody. I'm going to draw just this straight line right here, okay? Straight vertical line. Let me actually just do this for you to make it, super more relatable. All right. So watch this, everybody. I'm going to grab this and I'm going to draw the line right here, right there. Okay. So this is 5 miles, right? That's 5 miles. So that's 5 miles as well. So if you want to figure out how far away Michael actually is, you got to subtract the distance that was already covered by his crazy X. That's what we're talking about here. And so, boom, if Michael's going 7 miles an hour and his crazy X can go 5 miles an hour, how far away or how quickly is Michael actually running away from his X? What's his actual speed going away from his X?
2 miles.
2 miles an hour, right? Everybody, does that make sense in reality? Does that make sense there? Michael's actual speed is 2 miles per hour because you have to cross out, you have to exclude what was already covered. All right. And so that brings us to today's sponsor, farmersonly.com. That'd be hilarious. But there it is. All right. There it is. And so I really want to make sure we understand this situation and why we actually subtract instead of add in certain situations. So another thing is pointing out, again, the story matters. Like the story of the problem matters, because if you see opposite directions and same directions and you don't care either way, then you're going to get screwed over. You're going to get screwed over. So yes or no, are we seeing and understanding why wording is so important?
Yes.
All right, sounds good. So Michael, good luck with that situation, man. Hope you have the best. So there it is. So there it is. So that's why, again, in this situation, because we have one car going 42 miles an hour and the other car going 27 miles an hour, you see that you need to actually cut out the distance that they both cover. And so if this is 42 and this is 27, you got to cut that out to get 15 miles per hour from here to here. That's why you got to cut it out. And so when you're looking at that, boom, subtract 42 minus 17 again will give you 15 miles per hour. So There it is. Let me actually move this over here in case anybody wants to take a screenshot of that. So move that right over there. But that's what happens. And so we have the 15 miles an hour. Notice how earlier we were already given the 150 miles right here, right? Right over there. Let me just zoom in on that one more time. We're already given 150 miles. So that's our distance. So I'm going to write that out right there, my party people. Now, everybody, is it fair that we can just go ahead and plug it in and figure this out?
Yes.
Yeah, absolutely. Absolutely. Distance equals rate times time. And so we grab that right there. Cool. My distance was 150. Let me zoom in a little bit. My rate, my true rate right here is 15 miles an hour. And then my time, that's just going to be T because we're looking for time right there. So I'm just going to say T. And so we got 150 equals 15T. Everybody be specific, please, and thank you. Be specific. What are we going to do here?
Divide.
Divide 15 by both sides.
There we go. Thank you. Was that Aldine or Cassidy?
Aldine.
What's up, Aldine? How you doing?
Okay, how are you?
I'm good, thank you. So yeah, divide both sides by 15. Divide both sides by 15 there. Booyah. And so there it is. On the right side cancels. On the left side, 15 divided into 150. What's that going to be automatically, everybody?
10.
10 what?
10 miles
per
hour.
What does T stand for here? Time.
10 hours.
10 hours. Yeah.
Oh, hours, sorry.
Yeah, remember, we're looking for time here. And that's going to be 10 hours.
Hey, coach, you think they'll actually trick us with that, like as in hours or in like on like switching it up?
Oh, hell yeah. They are. It's not a trick either. It's not. I know that it can seem and feel like a trick when you're going in one direction with the problem, but then you don't really see it. You got to do that one little thing at the end. Trust me, I get it for sure. But the idea here, man, is really just understanding that if there's an extra step, that we'll commit to that step. Because when you treat it like a trick, it almost makes it feel like, you know, they have something over you that they're trying to like beat you down with. But if you notice that it's in different units, then boom, be like, all right, cool. Just got one more step here. Make sure they're the same units. And that's it. Does that make sense?
Yes, sir.
Yeah, coach. Thank you.
Cool. Again, don't ever frame it as you're the victim. No. Frame it as other people are the victim because you noticed what you need to do. Someone else probably didn't.
They doing a hard
that's
shit, pretty much.
Yeah, that's how we want to frame it. And so with that said, gang, so pop quiz. If you got a problem with two objects in the same scenario and they tell you that those objects are going opposite directions, what do we do with the rates?
Add.
That was quick. All right. If we got a situation where they are going in the same direction, what do we do?
Subtract.
All right. Sounds good. Final one. This might trick some people. Let's go ahead and say I bring my water bottle, right? I got my water bottle right here. And let's say the problem is I'm going this way. The water bottle is going this way. Are we adding or subtracting the rates?
Add.
Adding.
Ooh, how do we know it's adding?
Opposite direction.
Opposite directions. If you're facing each other, that is still opposite directions. If you're going toward one another, if this water bottle is coming toward me and I'm going toward the water bottle, look at it like this, everybody. Watch this. Pointing this way. What happens after we cross the middle point? Opposite directions. Facing each other is opposite directions. Remember that. Facing each other is opposite directions. There's a problem where they could talk about two speedboats are racing toward each other and they're going to collide. How long will it take? You still add the rates for sure. You still add the rates. So did that ever get anybody on a test? We got objects going in the same direction. Did that ever get anybody else?
It did at first, but since you're making it easier now, it's not going to be a problem anymore.
Hey, right on. And remember, it's not just about, making it easy in the moment. It's about being confident that you can see it at the crack of dawn, the moment you wake up, if someone presents that problem to you, you ain't gonna get tricked. You could literally wake up, first thing you do in the morning is look at that and be like, okay, opposite directions, that's going on, cool. Yeah, like that's really what the point you want to get to is. Not, oh man, I need to do like 5 of these problems before I can actually feel confident. No, confidence is I could do it first thing in the morning and I'm good.
I wish all math was like this.
It can be if you're in my all-access pass. So let me go ahead and shout everything out here.
I have one more question. I'm sorry to cut you off.
Yeah, what's up, Joshua?
What if they have like, because I've actually had one of these on a test before. I had 3 objects. Like one is going like right, one is going left, and then another one going right. I had 3 objects going in opposite directions. So how do you do that one? Because I know 2 of them are going in the same direction, and the other one is going in the opposite direction. So how do you? That's the one I got tripped up on.
Yeah,
so
that's a fair question, and I'm gonna actually need to see the question to be able to give you good advice on this, simply because you didn't tell me what they're looking for. So I need to know what you're looking for in the problem.
They were
and I
looking
can tell you exactly what to do.
They were looking for the time.
So time it takes for what? So if you have an example of it, you can find an example of it, take a screenshot of it, text it to me. I got you all day, but I got to be able to see something like that for sure.
Okay.
Yeah. So with that semi-party, people, this is a free class. And so tomorrow, what we're going to be doing in tomorrow's class in the next 2 hours is going to be going over this and adding the other situations. So today, what we did was we went over a situation of, hey, we have 2 objects and they're either going apart or going in the, toward each other or same direction. That's all we went through. Other situations look like this. Instead of 2 objects in the same situation, you got 1 object in 2